All right, this is page 2 of lesson 2.1, applications of percents. And now we're going to look at a different type of problem. The last page we were just reviewing problems, finding percent of a value, which was essentially multiplied the percent to the number. Here, we are trying to find the whole. And so when we look at a fraction, I'm going to put a fraction, I'm going to use this line just to make my fraction bar here. On the top, this is the part. And that's what we were looking for in the first set of problems. So when they said, like, what's 20% of 60 or whatever, that's what they're trying to find there. But the bottom, that is your total or the whole amount or the original. And I use these three terms because usually in these type of problems, one of these numbers describes what you're looking at. But sometimes talking about the original value makes more sense than the total or the whole value. So starting on the first one, 18 is 20% of what number? So 18 isn't the total or the whole, 18 is the part. And one way to recognize that usually is, it's is. They have an is in between. And when they say of what number, of is your unknown, and that's going to be your total. So that's what we're trying to find here, is 18 is a part of some number. It's 20% of some number. We don't know what that is. Now, in the other problems, to solve, we wound up multiplying by the percent in decimal form or fraction form. So to do this, to find the whole instead of the part, you're going to do the exact opposite. You're going to divide by that percent as a decimal or a fraction. So I think it's easier to divide it as a decimal. So in this problem, I'm going to take 18 and I'm going to divide it by 0.20. And so we'll do that on our calculator. So 18 divided by 0.20, enter, and we get 90. So if we go back to our original problem, 18 is 20% of 90. And now it kind of makes sense, right? So 90 has to be a bigger number, right? Since 18 is 20% of this, so that had to be a bigger number. And you just divide to get that. All right, let's take a look at the next problem here. If 45 students represent 75% of the class, how many students are in the whole class? Remember, whole number? So if we're looking for the total, 45 isn't the whole class. This is just 75% of the class. And so once again, you're going to take your number and you're going to divide by the percent, either in decimal or fraction form. I'll finish this and I want to talk about fraction form afterwards. So we're going to do 45 divided by 0.75, and we get 60. So the entire class size is 60. And just to kind of give us a visual of that, if this represents the total class size, I'm going to cut that in half, so that would be 50% here, right, if I cut that. And then if I cut these, this would be 25%, and then this would be 75%, right? And we found out that looking at 75%, so this value right here, this represents 45 of this 75% is 45 students, right? So from here to here, that's 75%, that's 45 students. That's actually 15 students for every 25%. 15, 15, and 15 is 45. This last part has to be 15 as well. So if I do 45 plus another 15, that gives me 60. So just to kind of give you a visual representation of that breakdown. So since 25% of the class is 15 and you have 4 25s, that's kind of your breakdown. Going back to this problem here. What if I decided to do 18 divided by 20 over 100 instead of the decimal form? Well, you can easily do that. 18 divided by, and then just use your fraction, 20 over 100. It'll still provide the answer for you. So either method will work there still. All right, going on to the next one. A store's 25% off sale saves you $12. What was the original price? So here you know how much you saved. You got to spend $12 less, but you don't know what the new cost is and you don't know what the original price is. But if we know that $12 was the 25%, oh, sorry, I should have put 0.25. We can divide that 12 by the 0.25, and that'll give us the answer. So 12 divided by 0.25, 48. So the original price was $48. So I just want to point out these other words that I put down here. Here we talked about the whole. Here we talked about the original price. These are terms we usually refer to. So when they're asking you to find the whole value or to find the original value, that's how you recognize it's going to be this situation, and you're going to be dividing by the percent. If you know the original value or the whole or the total, then you're going to multiply, right? But if you're looking for it, you're going to divide. This problem is different. A shirt costs $36 after a 10% discount. What was the price before the discount? This means the original, but I want to be real careful. They did not give us the same type of information as they did in problem 3. We don't know the discount amount. We know the cost after the discount. So this is the original price minus the discount. So this problem, you can't just divide by 10% because this isn't 10% of the original. What percent is this of the original? So this problem requires us to think a little deeper about this. So let's say this represents our 10%. That's our discount amount. Then if we didn't pay 10%, how much percent did we pay? What is the rest of this? Well, percent means per 100, so the rest of this must be 90%. So this cost is 90% of the original. So you're actually going to take 36 and you're going to divide it by 0.90. And that will give you the original value. 36, sorry, I'll find a better spot for this. There we go, 36 divided by 0.90, 40. So the original cost of the shirt is $40. Now, this is the first time you've seen a problem like this. We're going to continue to do and look at more problems like this so we can recognize the difference between this problem and this problem. So usually on day one, when we first see this, it's kind of mind-blowing, and it's like, how do I recognize? You'll get better at it, and we're going to work over it over a period of days. So you'll see this multiple times, and it'll start to make more sense as you continue to do these type of problems. All right. The last part of this is we're going to find the percent. We've already done problems similar to this. So here we know the part and we know the whole, right? So we know the part and the whole. We're just supposed to find the percent. So typically you just got to put the part on the top, the total on the bottom, and change it to a decimal or a fraction, either way. So here we're going to do 18 over 60. Well, it is a fraction now. We want to change it to a decimal. So we're just going to do 18 divided by 60, and that's our decimal value. Now, you could also put it in as a fraction. I'm going to do that, 18 over 60. And then you could use the fraction to decimal function here. So if you go second and hit the table, this changes it from a fraction to a decimal. You could do it that way as well. Both of those work. If that is the decimal value, what's the percent? Well, you can either multiply this by 100, so you just go times 100, that gives you the percent. Or you could move the decimal twice, 1, 2, that gives you the percent. All right, let's take a look at the next problem. A student got 45 questions right out of 50. Well, 45 is the part they got right. 50 was the total number of questions. So if you divide this, you get 0.90. Which, move the decimal twice or multiply by 100, you get 90%. All right, let's take a look at number 3. you saved $12 on a $48 purchase. What percent did you save? So 12 is the part that you saved. 48 was the total cost, or the total value originally. So that's the original price. And if we do 12 divided by 48, I think we get 0.25. Yep, 0.25. So this would be 0.25, which is 25%. All right, this one here, the car's value decreased from $25,000 to $22,500. So this is the original, right? So if it's the original, it'll go on the bottom, and this is the part, right? The how much it's worth afterwards. And so it's same type of process. We're going to take 22,500 divided by 25,000. So 22,500 divided by 25,000 is 0.9. So that means it retained 90% of its value. So we want to be real careful on how this question is asked. This is how much the original value is. The question is, what percent did it decrease by? So if it was 25,000 and it's now this value, that means it's 90% of what it was. So you're going to have to take 100 minus 90. It is a 10% decrease. So this one had a little bit of a trick to it, right? Because it didn't decrease by 90%, right? That's just 90% of the value. And so we'll talk about a way to solve these type of problems later on in this lesson. But that is the end of page 2. So continue on to the video for page 3.